Welcome back to the deep dive. We've got a really interesting one today for anyone who spends their days staring at architecture diagrams or, arguing about microservices.
Oh, yeah. We've all been there.
Right.
Yeah.
Today, we're looking at a piece from Aaron Rose's Secret Life of AWS series. Specifically, it's part 48, his take on what he calls the central nervous system of the cloud.
It's a great read. I mean, it tackles that one problem pretty much every engineer faces eventually, the spaghetti architecture.
Oh, the inevitable tangle.
Exactly.
We start with something so simple, like, I just need system A to talk to system B.
There's a single line on the whiteboard.
Right. A user signs up, send a welcome email, easy. But 2 years later, you look at the whiteboard, and it looks like, a conspiracy theorist's map with red string everywhere.
Yeah, that is the classic glue code trap. We focus so much on the applications, the endpoints, that we treat the space between them as just plumbing.
Just dumb pipes.
Right. And before you know it, you're maintaining thousands of lines of code just to move data from left to right.
And that's really the core mission of today's deep dive. We are going to explore how to rip out that plumbing, or at least stop building it by hand using Amazon EventBridge.
And Rose uses a really great narrative device in the article to explain this. He introduces us to two characters, Timothy and Margaret.
Timothy being the builder.
Yeah, Timothy is the practical one. He's just trying to ship a feature. And Margaret is the seasoned architect who comes in with the dreaded red marker.
We've all met a Margaret. Or, maybe we are Margaret.
Hopefully by the end of this deep dive, you listening will be a bit more like Margaret.
So let's set the scene here. Timothy has a task that sounds super standard. The business has signed up for a third-party payment processor.
Let's just say it's Stripe. The article implies a generic provider, but...
Sure, Stripe works. So his job is to handle the webhooks from this provider.
Standard stuff. When a payment clears, fails, or gets flagged for fraud, this external system shouts, "Hey!" over the internet.
And Timothy's infrastructure needs to catch that shout and do something with it.
Exactly.
So Timothy goes to the whiteboard. And honestly, looking at his plan, it's exactly what I would have built maybe 3 or 4 years ago.
Oh, absolutely.
He sketches out an Amazon API gateway to receive the HTTP request.
Yeah.
That triggers a Lambda function to parse the JSON.
Yep.
And then that Lambda publishes the message to an SNS topic, simple notification service.
Okay.
And finally, that fans out to some internal queues.
It is the absolute classic serverless pattern.
The API to Lambda to SNS trifecta.
You see it in tutorials literally everywhere.
Right. But Margaret walks in, takes one look, and uncaps the red marker. She just starts crossing things out. Why? What is so inherently wrong with that setup?
It's not that it doesn't work. I mean, it functions.
Sure.
But it is incredibly wasteful. Margaret's critique is that Timothy is building custom infrastructure just to act as a catcher's mitt.
Just to catch data.
Right. Think about the overhead there. You have to configure the API gateway. That means throttling, security, defining endpoints.
You have to worry about CORS headers, authentication.
Exactly. And then you have to write the Lambda function. That is code you own now, code you have to patch, libraries you have to update.
Unit tests you have to write.
All of that effort just to say, message received, passing it on.
It's undifferentiated heavy lifting.
Yeah.
You're building a custom door frame just to let someone walk through a door.
Precisely. So Margaret argues that we need to stop building nets and start using an event bus.
Okay, let's pause on event bus. Because I think for some of our listeners, that term might trigger some severe PTSD from the 90s.
Oh, the old enterprise service bus.
The ESB.
Yeah.
Those bloated XML-heavy monstrosities that cost a fortune and took a year to implement.
Yeah, this is definitely not that. In the AWS context, specifically with EventBridge, the event bus is a highly lightweight serverless router.
And it's actually already there, isn't it?
It is. Every single AWS account comes with a default event bus right out of the box.
It's the one listening to AWS services themselves, right?
Correct. If an EC2 instance changes state, or an S3 bucket updates, or a code build project fails, those events are effectively hitting the default bus whether you are listening to them or not.
It's like the background chatter of your cloud environment.
Exactly. It's always humming.
But for Timothy's payment problem, Margaret doesn't use the default bus. She spins up a custom event bus.
Right. She creates one and names it Checkout Application Bus. Think of it as a dedicated lane on the highway specifically for application-level events.
So it keeps the noise of the infrastructure separate from the signals of the business.
Exactly. You don't want server restarts mixing with payment failures.
Okay, so we have the lane. But this is where the article really surprised me. Timothy's original plan had that API gateway to catch the incoming data from the payment provider.
Right.
Margaret deletes the API gateway entirely.
She does.
How do you get the data onto the bus if you don't have a public endpoint to listen for it?
This is the killer feature. Partner event sources.
Walk me through this, because normally if I want to integrate with a SaaS provider, say Datadog or Zendesk,
Yeah.
I have to give them a URL to hit. I have to open a port, essentially.
Not anymore. Amazon has actually gone to these major SaaS providers, companies like Stripe, Auth, Shopify, Datadog, and they've integrated directly on the back end.
Wow.
So instead of the provider sending a webhook over the public internet to your API gateway, they drop the event directly into your EventBridge bus.
That sounds almost too easy. How does the handshake even work? Is it secure?
It's strictly permission-based and highly secure. You go into the partner's dashboard, let's say Auth, and you say, send events to my AWS account ID.
Right.
Then you go into your AWS console and say, accept events from this partner. Once that handshake is done, the events just appear on your bus.
So that entire ingestion layer, the API gateway, the Lambda parser, the security configuration for the endpoint, it just vanishes.
Poof, gone.
Right.
And think about the security implications there. You have massively reduced your attack surface.
Because there's no public URL.
Exactly. You don't have a public API endpoint sitting there waiting to be DDoSed or exploited. The connection is happening completely within the AWS backbone.
That is a huge win. But I have to play devil's advocate here for a second. Timothy might look at the pricing page and say, wait, EventBridge costs money per million events. API Gateway has a free tier. Is this actually cheaper?
Margaret addresses this with the total cost of ownership argument. Yes, EventBridge has a transactional cost, but subtract the cost of the API gateway running 24/7.
And the compute time for the Lambda to parse the JSON.
And most importantly, subtract the engineering hours.
The how many weekends do I spend patching this cost?
Exactly. When you factor in maintenance, security patching, and the sheer time it takes to write and test the glue code, the bus is almost always cheaper.
Okay, so we've got the data onto the bus efficiently. No custom glue code. Now comes the routing. Timothy was originally going to use SNS, Simple Notification Service, to blast this out to everyone.
And that's where the metaphor of the central nervous system really starts to click. SNS is a broadcast system. It's like a radio tower.
It's just yells.
It blasts the signal, and it's up to the receivers to decide if they care. It's dumb.
It's a megaphone. Hey, everyone, a payment happened.
Right. And if you have 50 microservices and only one of them actually cares about that payment, 49 of them have to wake up, check the message, realize it's not for them, and go back to sleep.
That's a lot of wasted compute.
EventBridge is entirely different, though.
Because it's intelligent.
Yes. EventBridge uses rules. And this is the part that I think is the biggest shift for developers. Content-based filtering.
Define that for us. What does it mean for the network to filter by content?
It means the event bus actually opens up the envelope. It looks inside the JSON payload of the event itself to make routing decisions.
Let's look at the example from the article, because the syntax is really cool. They're dealing with payment transactions.
Yeah.
So you've got successful payments, failed payments, and the really scary ones, fraud.
Right. So Timothy has a specific requirement. He needs to isolate transactions that have a status of failed and a fraud score of over 90.
Okay. In the old world, the Timothy world, how do you build that?
You'd probably send every single failed transaction to a Lambda function. Inside that function, you'd write Python or Node.js code.
Like an if statement.
Exactly. If payload.status equals failed and payload.score is greater than 90, do something.
You're writing business logic in code just to route a message. You're maintaining that script.
Right. But Margaret shows him how to do this in the infrastructure configuration instead. She creates an EventBridge rule. It's just a simple JSON object.
How does it look?
It filters for status equals failed, and then for the score, she uses a numeric logic operator, greater than 90.
So the rule is declaring, I only care about events where this number is greater than 90.
Precisely. If a transaction comes in with a score of 89, the rule doesn't trigger. The event is ignored. You don't pay for downstream compute. You aren't executing a Lambda function just to say no thanks. The AWS network itself is performing the logic.
That is a massive mental shift.
Yeah.
You are moving logic out of your application code and pushing it directly into the AWS Cloud Fabric.
Which is safer, easier to visualize, and way easier to change without deploying new code builds.
Right, because if the business decides tomorrow that the fraud threshold is 85, you just update the rule configuration.
You don't redeploy the microservice at all.
But isn't there a risk there? If the logic is in the infrastructure, isn't it harder to debug? Timothy can't just step through it in his IDE like he can with a Python script.
That is a very common concern. But think about the alternative. Debugging a distributed system where logic is buried in 10 different microservices inside nested if-else blocks is often way harder.
That's a fair point.
With EventBridge, the routing rules are explicit. You can see the pattern right there in the console. It completely decouples the where does this go from the what do I do with it.
So we filtered the fraud. Now, where does it go? Timothy's diagram just fanned everything out to generic queues.
This is another massive win for EventBridge. SNS is limited in where it can send data, mostly just SQS or Lambda. EventBridge has direct targets.
Meaning it talks to other things.
It can talk to over 35 different AWS services directly.
So it skips the middleman yet again.
Exactly. In Margaret's design, she sets up 3 distinct paths. First, that fraud rule we just talked about. If that matches, score over 90, it doesn't go to a queue. It routes directly to an AWS step functions state machine.
Oh, that makes perfect sense because a fraud investigation is a workflow, right? Step 1, lock the account. Step 2, email the admin. Step 3, generate a report.
Right. And the bus triggers that workflow directly.
No glue code required.
No Lambda function whose only job is to start the step function. The bus just does it.
Okay, that's path 1. What about the legit money?
Second path. For successful payments, she has a rule that routes them directly to an SQS queue called fulfillment queue. That's for the shipping team.
Standard async processing. That queue acts as a buffer so the warehouse system doesn't get overwhelmed.
Correct. And the third path is a catch-all. She creates a rule that sends all transaction data, success, fail, fraud, everything, directly to Amazon Kinesis.
For analytics.
Right. So the data analytics team gets a real-time stream of everything happening without having to ask the payment team to double send data or write new logs. It's totally decoupled.
It really is cleaner. You have 3 different consumers: security, fulfillment, analytics, all feeding off the very same bus, but completely unaware of each other.
And if you want to add a fourth, say a loyalty rewards program, you just add a new rule. You don't touch the existing systems whatsoever.
It's a beautiful architecture. But Timothy, being a good engineer, asks the doom question.
The what if question.
This looks pretty on the whiteboard, Margaret, but what happens when things break?
Right. Specifically, what if that security step function is down? Or what if I push bad code to the fulfillment service and it just crashes? Does the event just vanish into the ether?
That is the big fear with event-driven systems.
Yeah.
If you miss the message, it's gone forever. It's completely ephemeral.
Margaret outlines 2 layers of defense here. The first is pretty standard: dead letter queues or DL queues.
Okay.
If EventBridge tries to deliver to a target and fails, say permissions are wrong or the target resource was accidentally deleted, it drops the message in a DL queue so you can inspect it later.
That's table stakes. Here's the pile of stuff we couldn't deliver. It's the undeliverable mail office.
But the second feature she mentions is the absolute game changer. It's called archive and replay.
This sounded literally like a time machine when I read the article.
It effectively is. You can configure the event bus to archive every single event that passes through it. It saves them indefinitely or for a set retention period like 90 days.
So let's paint a scenario here. It's Black Friday. Traffic is peaking. I deploy a bug to my fulfillment service. For 2 hours, it's rejecting orders because of a typo in my code where I misspelled address.
In the old world, that is a resume-generating event. The data is lost or corrupted. You're spending the next week trying to scrape logs to reconstruct the orders, calling customers to ask what they bought.
A nightmare. I'm sweating just thinking about it.
With archive and replay, you fix the bug in your code, you deploy the fix. Then you go to the EventBridge console and say, replay all events from the checkout application bus between 2.0 p.m. and 4.0 p.m.
And the bus just resends them.
It resends them exactly as they were with the original timestamps. Your fixed service processes them correctly. You have effectively gone back in time and repaired the damage.
That is incredible. It turns a catastrophic failure into a manageable operational task.
It's the ultimate safety net. It allows you to move faster because the cost of failure is vastly lower. You know, you can always just hit rewind.
It also seems great for testing. Like, if I want to test a new feature, I could replay real production traffic against my staging environment.
Exactly. You don't have to write mock data. You just replay yesterday's actual events against your new code to see if it holds up.
Okay, so we've got the bus, the smart rules, and the time machine. But there's one final objection Timothy raises. And frankly, it's the one I hear most often from developers who are skeptical of event-driven architectures.
The black box problem.
Right. I'm a developer on the fulfillment team. I'm supposed to listen for a payment success event. but I have absolutely no idea what that JSON looks like.
Is the field called user_id? Or user_id in camel case? Or capital user in A? If I guess wrong, my code crashes.
And usually the solution is go read the wiki, which, let's be honest, is outdated the moment it's written.
Or go bug the team that wrote the producer, which entirely defeats the purpose of decoupling. If I have to have a meeting with you to understand your event, we aren't decoupled.
Exactly. Margaret introduces the solution here, the schema registry.
Right.
How does that actually work? Is it just a manual documentation page?
No, it's automated. That's the real beauty of it. You can turn on schema discovery in EventBridge. It acts sort of like a wiretap. It watches the traffic flowing through your bus in real time. It analyzes the JSON structures and automatically deduces the schema.
So it's actively learning the shape of your data as it flows.
Yes. It says, oh, I see a payment cleared event. It always has a string called id, a number called amount, and a Boolean called isPrime. And it records that precise definition in the registry.
That's super handy for documentation.
Yeah.
But does it actually help me write code?
That is the real nugget right here. It's called code bindings. Margaret explains that once the schema is in the registry, a developer can go in, select the event they need to consume, and just click download code.
In their language?
Yes. Java, Python, TypeScript. It generates a class definition that is strongly typed directly to that schema.
Whoa. So I don't even have to write the class.
Uh-uh.
I just download the binding, and my IDE knows, okay, this object has a fraud score field, and I get autocomplete.
Exactly. It solves the biggest complaint about event-driven architecture, that it feels loose and untyped. The schema registry tightens it all up.
That's amazing.
It makes the central nervous system not just a router, but a Rosetta Stone. It ensures that the brain and the limbs are actually speaking the exact same language.
That is the total aha moment for me. It's not just moving data, it's understanding the data.
Correct. And it keeps the teams honest. If the producer changes the schema, the registry updates, and you know about it immediately.
So let's wrap this up. By the end of the article, Timothy is erasing his whiteboard.
The API gateway is gone. The custom Lambda parser is gone. The complex fan-out logic is completely gone.
And in its place is a single clean pipeline. SaaS provider to EventBus. EventBus branches out to microservices.
It is cleaner, it is cheaper to run, and because of the rules engine, it is significantly smarter.
It's so interesting how the conversation shifted from how do we connect these things to how do we make the network do the work for us?
That is the key shift. Margaret says it at the end. The architecture wasn't just decoupled anymore, it was intelligent. The network is no longer just a dumb pipe carrying water. It's a router that actually reads the mail and knows exactly where it needs to go.
And it handles the security logic and the retry logic and the archiving. It allows the developers to focus on the business logic inside their services rather than the routing logic between them.
Which is really what we should all be striving for. The best code is the code you don't have to write.
Absolutely. So here is the challenge for you listening right now. Think about your current project. Think about that whiteboard in your office or your digital canvas. Where are you acting like Timothy?
Where are you building dumb pipes? Where are you writing a Lambda function just to say, if X, send to Y?
And ask yourself, if the network can read the data, why are you still writing code to route it?
Maybe it's time to find a red marker.
Less code is usually the best code. That's it for this deep dive into the secret life of AWS. Thanks for exploring the central nervous system with us.
Always a pleasure.
Keep building, but maybe build a little less glue. We'll catch you on the next one.